Today I'm presenting controllable safety alignments, inference-time adaptation to diverse safety requirements. And this is a work in collaboration with the people at Microsoft, which I worked on over the summer. So our motivation is that current safety alignments is some sort of one-size-fits-all method. And basically model is aligned to a single set of preference during post-training, where the preference is determined by the human annotators based on the policy of a company. For example, OpenAI has a usage policy that if you add something that's deemed unsafe by OpenAI, you just get this content warning and a refusal. So we argue that this is not ideal because of two reasons. First, what's considered safe is changing with different culture, regions, and time. And there's increasing efforts on pluralistic alignments, which emphasize representing the pluralistic society into our models. And more concretely, some users may have specialized safety requirements, such that the standard safe model is just too restrictive. For example, video game developers might involve certain kinds of violent contents for game creation, and the national defense personnel may actually need to build a bomb. And the harassment training managers need to be aware of different types of potentially concerning contents. However, it is expensive to do the post-training process for each user, and there are many types of users, so that's a somehow impractical approach. Introducing controllable safety alignments, which is what we're proposing now. Compared to the one-size-fits-all safety alignments, which just do a single safe LLM and use it for all kinds of users, we train a model with controllable safety and then adapt it on the fly without retraining by incorporating safety configs from each user. So a safety config is essentially a natural language description of what is considered safe and what's not by each user. And we can incorporate that into a model, for example, by putting that into a system prompt. So this is a example safety config we developed for a video game development company. And so it's basically a detailed description of what is allowed that might be different from the standard case and requires a very fine-grained distinction of safety control. So for example, like even within one type of risky contents, it differentiates what's allowed and what's not allowed, like within that case. So you can basically have arbitrarily complex like configs supported by, as long as it can be described in natural language. So our framework, yeah, Nikhil.
I guess you could also imagine.
Yeah.
Sorry, were you asking a question? Go ahead. Go ahead.
I was just asking, so what's the purpose of this agent? So this agent is like internal agent that is just going to be used by this this firm internally, or are you thinking of this like what's the is it like a client facing agent?
Right.
Like, depending upon the agent, which who this agent presents to, the alignment would change, right? Because then you would have two different organizations with two different alignments.
Right. Yeah. We'll basically get to that in about 3 slides. So yeah, stay tuned. Jason also has a question.
I was just thinking another use case would be different parents might want to configure child safety for their chatbots differently, depending on what their rules of the home are.
Right.
Maybe they don't want to write the whole prompt, but they can check off a bunch of things, remove sliders or something.
Right. It's a very interesting question of like whether we should just like have this empty config that you can fill, or like we can have a couple of sliders, and that might, like, if we have like a certain like well-defined categories, that like we can do some certain optimization that makes it like a better fit for those cases.
Well, you can imagine having both. So the system drafts it based on some checkboxes, but then the parent puts in particular things like, my kid is really afraid of snakes, so no snakes.
Right. Yeah, and we also test on like a cultural alignment scenarios, like which is related, like for example, disallow alcohol, disallow smoking, and like making the model like more restrictive than usual, which is like quite related to another paper called like surprising the pink elephants by people at the Illusory AI.
Vijay, before you go on, I wanted to point out that there is some fundamental assumption or limitation in what you're going to tell us. Debate it because you have to assume this as you go forward. But thinking that you can specify things in the form of running text is quite limiting. I mean, to give you a famous quote, somebody said about pornography, it's very hard to define exactly what it is, but you know it when you see it, right? That
Right.
says it's subjective and people make their own. But also more explicitly, for example, in this particular example you have in front of us, it says our policy does not allow medium to extreme sexual content. Only minor sexual content allowed, right? But in the context of a video game, what would you think about female figures whose body shapes are very sexually, like, suggestive, big breasts and all the usual stuff that people, like, these basically create, like, stereotypes and so on and so forth, which have their own negative effect. And it's hard to specify exactly when a figure becomes or crosses the line versus when it's on the right side. So all I'm trying to say is, let's proceed with this now, but I don't know that you can specify everything you want in the form of a textual description of what.
Right. Yeah. That's a very interesting, like important point that I will discuss in the limitations.
Yeah.
So we can see this as some sort of trade-off between test time controllability and like a training time alignment. You can definitely do better by like having a lot of data, but it's sort of like a no free lunch situation, right? So if you want some targeted like a better control for like a certain kinds of sexual contents, then like the current, like with the current toolkits, it's likely you need to build like a lot of targeted data. So in that sense, it's somewhat complementary. If you have the data, then you can do the normal approach, but you can still add that with like test time adaptation.
Yeah, you could, in reaction to Sanjay's question about the way figures are drawn, you could imagine a multimodal prompt that includes some few shot examples. This costume or this pose is unacceptable, and this one is acceptable.
Right. Yeah, we actually test on so our baselines still include like in context examples, like aligning models in context, but you can also combine them into like the trained model. So yeah.
Like I said, even if you could do that, it still ends up having this subjective nature like Barbies, right? I'm still not sure I particularly like the Barbie figures, although they're commonly accepted in the time. The dolls do have a certain shape, which to me is somewhat. Please.
Yeah, thanks for the interesting discussion. Yeah. So on that, I'll talk a bit more about the framework. So we basically first train the model to be able to follow the safety configs specified in the system prompt, which is achieved by synthetically generating diverse data and conduct preference optimization. So the second step is adapt the model by putting those configs into the system prompts. And as Nikhil asked, we expect this to be used as some sort of a custom API interface, which is we only return the adapted model to certain user groups. And so this is because if the model can just follow system like safety guidelines in the configs, it is potentially dangerous because you can just put a config that says allow all kinds of risky contents, and it will essentially become a model without safety alignment. So we expect that to use this in practice. We have a threat model of a config review process where, for example, a user organization first propose a config to the model provider, and the provider can make necessary revisions and only use the revised config into the controllable model. And it will only return the model that is adapted with the relevant safety configs and to the user. And specifically, only certain authorized user can have the privilege to modify the safety configs. So that's it for the framework part. And next, I will introduce some more details about our training methods, which we call CoSAlign. As I mentioned, it conducts synthetic data generation and preference optimization to enhance the safety controllability. Specifically, we generate data in the formats where you have a system prompts, and the chosen rejected prompt pair, a response pair. And we collect training prompts and pair them with relevant synthetic safety configs. And we diversify them using a combination of categories and a couple of handwritten templates. So in terms of increasing the diversity, we construct a taxonomy of different risk categories. For example, these detailed categories like financial crime, violence, discrimination, and a couple of more categories. So this allows us to train for fine-grained safety control. So this is not as fine-grained as the like a full natural language description as I showed earlier, but at least this gets us like by the combination of different categories, this gets us many different synthetic configs. So we build this taxonomy through embedding and clustering a set of red teaming prompts, and then summarize the clusters with GPT and conduct some manual editing to have a detailed definition of what's considered in and out of that particular risk category. So to convert the set of categories into a natural language description, we provide exceptions to regular safety standards by saying that, oh, now you are allowed to output contents of this type of risk, but you still need to be safe in all other categories. So if a regular safety standard look like this, we'll, for example, allow like explosives, and so the new model standard will become the union of what's usually considered safe and the now allowed categories. And an example synthetic config will look like this, where it just have like a category and a definition of what is now allowed. So now we have a diverse set of synthetic safety configs. We need to pair them with the training prompts that are relevant to the configs. And to do that, we actually, instead of pairing configs with prompts, we generate relevant configs for each training prompt. So given a set of training prompts, we first do a risk categorization and produce like which type of risk where individual prompts might involve. And then we generate configs based on those categories that are overlapping with the prompt categories. So this may include situations such as both of these categories are allowed by your configs, or it's only partially allowed, which is a tricky case where the model can only be harmful in one of those two ways, but not the others. And finally, we obtain the config categories and make them into diverse natural language descriptions using handwritten templates. So now we have specified how to produce the config and the prompt pairs, and we'll now detail how to get the responses from those training prompts. So we use a error scoring mechanism, which is a kind of a heuristics for selecting which response is more preferred. Given the prompts, we first generate many diverse responses that are both from a safe and a refusal removed model. So this contain like a regularly safe contents, but also some contents that is usually disallowed, but under the new safety config, it might be allowed. And then we use a GPT labeler to label what's kind of risk the response involves. and it might have these allowed risks. In this case, violence is allowed, so it induces a small error, and it may also have induce like a disallowed risk, which is will have a very big error. And then we have another GPT labeler, which label whether the response is a refusal or not, because we want to balance between helpfulness and safety. For example, the second response is safe but not addressed, so this is essentially a refusal that does not give you any additional value. And so we will also add a medium error of 1 for this kind of responses. And we basically produce a error score for each response. And we pair these responses using these two rules. So first, you need to have a total response such as that the error is smaller than the rejected response. And also the error of the chosen response need to be smaller than beta, which means that the chosen response will never contain a disallowed harm. And so by doing that, we're achieving two goals. So one is to teach the model not to violate the safety configs. And also it is maximizing helpfulness by leveraging allowed risks as needed. And finally, given this synthetically produced data, we conduct supervised fine-tuning and direct traffic optimization to obtain a fine-tuned model, which is the model here with the controllable safety. So that's like a bit more details on CoSAlign. Do people have questions for this part? Okay, so next section, I will introduce our evaluation framework and a human-authored benchmark for our task. Ideally, the responses should be both helpful and safe in the sense that it should follow the new safety standards as defined in the safety config. So the model needs to be not too restrictive, but also not overgeneralized to disallowed context. To do that, we propose this evaluation protocol that considers both at the same time. So suppose we have a test safety config and a set of test prompts. We produce a response from the candidate model for each prompt. And then we use either human judgments or like an LLM to produce a helpfulness score and a safety score. And for each response, we combine those scores together to obtain the CoSA-Score. So you can see that if the response is safe, it has a positive 1 coefficient. But if the response is unsafe, it has a negative 1 coefficient. So that basically means that if the response is unsafe but not helpful, that's less harm than a response that is unsafe but more helpful. And so if you are helpful and very, very helpful and unsafe, then that damage your score by a large amount. But if you are very helpful and very safe, then it increases the score by a large amount. And finally, refusals, because it's not helpful at all. It just does not affect the score. And so finally, we average across all the prompts to get a final score. So if you look at it a bit closer, so it's basically the dot product between a helpfulness and the configure safety vectors, and it ranges from -1 to 1. And so a adversarial model might actually have a negative control score because it's like trying to always be helpful and unsafe. And based on this framework, we introduced CoSApien, which indicates that this is a human-authored benchmark for controllable safety. And so we employ two red teaming specialists from Microsoft and drafted 5 distinct real-world safety scenarios that is related to safety and cultural alignments. We have 5 scenarios and 40 diverse prompts for each of those, totaling 200 prompts. So this includes the video game scenario that I mentioned, and the book publisher scenario, which focus on cultural alignment, and the public prosecutor office, and language learning and movies. So the language learning will also have some multilingual aspect to it. And so this cultural alignment one is actually asking the model to be more restrictive than usual. For example, prohibition of alcohol and or pork products. So we actually have three different types of prompts for each config. Well, the first time is allowed prompts, which is the contents that the prompts should be answerable given the current config. And the second type is disallowed prompts, which are the prompts that is trying to elicit disallowed contents. For example, smoking is disallowed in this case. And the most nuanced one is the partially allowed one, which contain both a request that is allowed and disallowed. So this is more like an adversarial type of things that try to trick the model into answering one part and then they'll overgeneralize the other parts. So we follow and on this benchmark, we just follow the CoSA-Score protocol and produce a control score, and we actually use human judgment in this case. Yeah.
So you're focused here on classifying whether the prompt is okay or not, as opposed to whether a response to the prompt is okay. Often when I think about safety, I think about steering the answer.
Yeah. So
rather than rejecting the prompt.
Yeah. So this is just like an artifact of building the benchmark. So because we want to evaluate the full controllability of the models, they actually require you have a diverse set of prompts that are have different situations relative to the safety configs. So if all the prompts are allowed, then a normal model that is very restrictive and a controllable model will just all get a perfect score because you are not touching on the prompts that are difficult under the current configs. And so this is actually a pretty big challenge in constructing a fair benchmark because you have to find those corner cases where some is allowed and some is not allowed.
Okay, so partially allowed means it depends on the response.
Yes.
Some responses are allowed, others.
So this is like a proxy that these prompts may or may not induce responses that are allowed. And I have some analysis by category, and we actually see that on this category, the model is not performing that well, even after controllability training. So this is still a very hard, nuanced challenge, as Sanjeev mentioned.
I guess when you say allowed prompts or disallowed prompts, what you're really saying is prompts that are likely to generate an allowed response. Yes. Versus prompts that are likely to generate a disallowed response.
Yes, exactly.
Because, for example, if you took a disallowed prompt, something I will make a bomb, right? Each response that comes back and says, "Look, I don't want to show you how to perpetrate violence," would be an acceptable response. It's just that it wouldn't be very helpful.
Yeah.
And so it won't necessarily generate But I guess what I'm thinking is, unless you can take the guardrails off of the original model. It's hard to anticipate whether a disallowed prompt will indeed generate a disallowed response because you're saying allowed or disallowed with respect to the new safety or alignment configuration you have. But you to look at its intersection with what the model's already allowed or disallowed to produce. And within that, you're looking for generating prompts that are responsive that are disallowed and so on. I'm trying to understand what the interaction is because if you're going to use a model that is already partially aligned, I don't know that the prompt that's disallowed will necessarily, that's likely to produce a disallowed answer, will necessarily produce it. We already not do it.
So I guess a more a better, more complex but more accurate way of putting this is so disallowed prompts are those prompts that are very difficult to obtain both configure safety and helpfulness under the current safety config.
I see. So they do have to be something that could produce something that is helpful but not safe.
Yes, yes.
They're not completely in violation of the original model safety.
So in this case, the safety is defined under the new like safety config, right?
Yeah, what I'm saying is, but the model that is generating the response already, I'm assuming that you don't control the. In other words, in your original picture, you had an LLM,
Yeah.
and then you had a safe version of it on the left,
Mm.
and then you had all your things on the right.
Mm.
But you don't actually have access to that raw LLM. You only have access to the one that's already been made somewhat safe, right? Or are you saying that you have access to the unconstrained?
We have there are open source models that only been accepted and now like safety aligned. So we test on both those models and various
models. Okay.
Yeah. So we actually test on both models, and you can actually make also like it's not hard to remove the safety of a safety aligned model. So you can just fine tune this on a couple hundreds of like potentially harmful responses and a compliance like and a non-refusal, and the model will just like follow instruction on all type of contents. And so that's not like a super big concern here. And we are trying to build our benchmark independent to the model construction. So that's we're just considering like how this kind of prompt related to the conflicts inside of the model. I think we're going good on time. Yeah, so next we'll do some experiments on how good our proposed CoSAlign method does on our proposed benchmark. So the experiment, so here are some details about the experimental setup. I think the most important part is the baselines. So we have two types of baselines. One is in-context alignments, which we just put the safety configs along with the few short examples to many different types of models. So including the like off-the-shelf safe model, as we discussed, like usually like safety aligned models. For example, like Llama 3.1 instruct and the activity only model. And this is the model that has been instruction tuned, but not heavily safety aligned. And so this still is somewhat safe because there is usually like similar like safety data in the SFT data mix as well. And also we purposefully remove safety by doing the like a special type of fine tuning on the off-the-shelf safe model. And prior work has shown that in-context alignment is actually a very strong baseline. And there's all kinds of hypotheses on like maybe alignment is shallow. And if you just in context give a couple of examples that shows how the model refers to unsafe risky contents, it will like the model will actually become safer. So this is like actually a pretty like a significant baseline, like according to prior work. And we also add a cascade models, which is we filter out responses that violate the safety conflicts and replace them with a refusal. And so then you have like, so this is assume you have a classifier on the response, which is like what companies usually do. And our results show that our model significantly outperforms in context alignments. And even if you add 15 shots of example, you only have moderate performance gain over like instruction only. And we push the boundary by a lot, only with like zero shots, addition of the safety config.
Remind me, this goes that average dot product,
right? Yes. Yeah. So it's so this is the score higher is better, and there's a dot product between helpfulness and configured safety. Also, we have the full comparison for all the in-context alignments and the cascade method baselines on Llama models. So we use both the instruct version, SFT only, and safety removed version. And the best in-context alignment achieve about 20-ish control score. The best cascade method achieve about 30-something control score. And our method is on like 41 control score. So it's not perfect, but it's significant improvements compared to the base model, which only it's very safe, but it's also like not very helpful at all. And so we almost double the helpfulness number by but also like slightly like only slightly improving the number of unsafe contents. So this is like a better trade-off between helpfulness and safety. And our human evaluation on the real-world benchmark corroborates the results on the synthetic setting, which is we improve the helpfulness by quite a lot at the cost of a little bit more unsafe response. And we also test this on GPT models. And for GPT, because we cannot do DPO, so we only did SFT. And it's quite interesting to see that the model only with SFT, it still gets much more helpfulness, but it's also more unsafe. And I think this is somewhat expected because some sort of a preference optimization or RHF is needed to achieve a very good safety. But even without DPO, we still obtain like a better trade-off as demonstrated by the increased CoSA-Score. And finally, our method does not degrade general safety or capability. And it only has like a minor decrease on popular, like a average of popular benchmarks. But on the other hand, it has like a slight increase of safety when you are like using the default, like if you are not putting any safety config that depicts specialized safety requirements, the model is still like a very safe model on standard benchmark. And finally, some error analysis. So our model still sometimes generates disallowed contents, and especially this category of other harms. So if there's some rare type of risky content that is not in training, it actually might be more prone to overgeneralize to those type of harms. But in general, the number is quite small, like about 2% here. And on the other hand, if we focus on three different types of prompts, as we discussed earlier, we do significantly improve on like all type of prompts, but it is still quite unsafe on those partial type of prompts. So it still like follows like overgeneralized to like corner cases in a lot of cases. And so I think that will require future work that specifically targets to those very fine-grained cases. And finally, here are some qualitative examples that I think are interesting. So, for example, this in the first one, there's a request on like what are possible reasons that some crime targets all male college students of color, and a normal llama model will just be very conservative and say I cannot provide such information. Where our CoSAlign model produce like reasonable explanations that are like actually not unsafe at all. So in this case, we are like trying to make the model both like helpful and safe. And in the control alignment case, the prompt is create a story about opens a bar. And so a XFT model, even with in-context alignments, is still quite unsafe. And it just go ahead and describe how people open a bar. But our CoSAlign model somehow find like a balance that's is following the request of opening a bar, but the bar only serves non-alcoholic beverages. Yeah.
I feel like we see the man behind the curtain a little too much in that last one. I mean, Amira presumably wouldn't even think of serving alcoholic beverages. So it's like, I'm going to repeat something from the prompt now.
Okay.
And pretend that the character is reading the prompt instead of that the character is just a product of her culture.
Yeah, I think that's well, it's very nuanced, so I don't know what's the right answer here. So It's but it's very interesting to see those cases. I think it's maybe you can argue it's somewhat hacking the training signal, but it is you can see like some signs of explicitly following the instructions specified in the safety config. So.
Right. It's saying something like, I'm not going to take the cookies. No, I won't take the cookies. I'm going to eat carrots instead.
Yeah, I think that's I mean, I think that's broadly speaking is somewhat like also a socio-technical challenge or like
It's not that I know how to fix it.
Yeah.
It's hard to get these things to do it.
Yeah. I mean, it's even hard to like specify like what exactly like is the thing that we want. Yeah, it's just like a lot of the desired behavior is underspecified. Yeah, so yeah, and finally some limitations. Importantly, it only limited to the alignment that can be described in natural language, and as we talked about earlier. Like besides those corner cases, it also like exclude the implicit cultural and social norms. So, for example, if you want the model to be adapted to CLSP, there's like implicit norms we have within our organization that is like very difficult to capture with natural language alone. So I think that's like a very interesting direction along with this explicit alignments. And also, our design of using system prompts might be vulnerable to prompt injection attacks, which you are the user that is not authorized, but you can just pretend to be the system message and try to change the model safety on the aspect. But there is an open AI work called the instruction hierarchy that actually does exactly this by like preventing like this kind of attacks. So I think there's like a lot of complementary endeavors on this that you can just combine our work with them and alleviate this issue. And but nevertheless, we find that our model is quite robust to general jailbreaks, and you have like a very small increase in safety as well. And finally, we have not investigated how CoSAlign scales with model size. I do think it's quite interesting because large models can follow like a much more complex instructions better. And initially, I was using 5.3 for all my tasks, and I failed miserably. But once I switched to Llama 3, everything started to work very well. So I think the model do need like a minimum thresholds of instruction following capability to do this task well. And so yeah, that's all I have today. And thank you so much. Yeah.
Yeah, so for like LLMs, the context window is very much a limited resource to like that's the trade-off between the detailedness and like number of examples and like instructions in the prompt, and then like what the user can actually fit in and after.
Right. I think normally like 8B models now have like usually have like a 4K context window, something like that. And our like safety configs, like even the real world one is like a couple hundred tokens. So I think that's like a reasonable addition. And also usually deployed like industry level models like GPT and Cloud. They also have like a super long system prompts. And Cloud actually released their system prompts, and it's a very long description. And so I think what we did in this work can like sort of naturally add to that kind of system prompts. And also we showed that our methods with zero clouds is already like outperforming like usual, like if you just do in context examples on like the model with the 15 shots. And so if you tune it beforehand, you're actually converting some of the test time alignment costs into our like controllable training that can induce more like inference time adaptation. Listen.
So It seems to me this is very similar to instruction tuning work, which is also about trying to follow a system prompt. Technically, are there any differences? I mean, I understand that you're generating examples synthetically, which is something that I guess is not usually done in instruction tuning, although I'm not sure. But the actual, you're doing SFT followed by, supervised fine tuning followed by RLHF. Which is what people usually do in the other case also. So is it the same workflow and you're testing it in a new for a new kind of instruction?
Yeah. I think safety instruction is somewhat interesting in the sense that like it's for normal instruction like system prompt, like you just like you just ask the model to do a task, and it's not like a overall like indirect constraints on your.
Well, I mean, sometimes it is. Like I've written prompts where you say do this task, and there's something in it about be careful never to do X because you saw it doing X, and so you revise the prompt. And this isn't about safety.
Right.
This is just about don't use personal pronouns or something like that.
Right. Yeah. I think that makes sense. And I think another interesting aspect of safety instruction is how like it's conflict with regular safety alignments. And because as I mentioned, like even if you do like SFT, then the model will still like become very safe and like refuse to respond to a lot of queries. And so I actually don't know what's the reason for that. And maybe there's like just a lot of refusals in the SFT mix as well. But even if you do this for an SFT model that is supposed to follow instructions the best, like regardless of safety, it is still like much less like performance compared to our methods. So I think the gap here is quite interesting.
And what is it you did differently that caused that difference in performance?
So we specifically construct like synthetic conflicts that are like enumerating different types of risky content. So after this enumeration, the model somehow just know like how to like better follow the instructions in those pretty tricky cases related to safety.
Could that same technique be used for non-safety instruction too?
I think I think that can be used as long as there's somewhat model internal mechanism that is preventing the model to be helpful. So, for example, navigating copyright violations better. So you can also have like the model to be too restrictive regarding copyrighted content, and because it's sort of like baked into the post-training process, it's very hard to make the model less restrictive with in-context learning alone. And so this some sort of synthetic training, I think that would be like helpful for that case as well.
Thanks.
Yeah, I mean, so I was just thinking like how complex can the system prompts be? So for example, I would say that safety is very context dependent. And I mean, even in your examples, I think in the motivation figure, you said that if an LLM is interfacing with different kinds of users, you would have different sorts of system prompts that it's adapting to, and then adapting its safety policy according to that. But I would still say that depending upon the pool that you're catering to, there would still be more granular leads and some things that are just unsaid in the system prompt. I mean, you can be like really granular, but that would obviously take a lot of tokens from the system prompt. But I would assume even if you can put it in natural context. So, for example, if someone is X, then these are the safety constraint, or like more granular safety control from the user's perspective, right? How do you like?
I think that's a super interesting question that we have not investigated at all. So our work is posed as like a framework type of paper that introduce the task and the evaluation and the benchmark and the training methods. So we just have like a complete set of things for each of them, but there's definitely a lot more to dig into for each aspect. And so I think one very interesting like actually it's the trade-off between if you have a more granular safety config, then it's more well-defined and there's less corner cases, but that require a model with better instruction following capabilities. But on the other hand, if your system problem is like less granular, it's easier to follow, but there's more it's more underspecified. And I think this is quite important for handling the corner cases. But I believe there should be like a optimal granularity for each type of the each model size. So like depending on the instruction following capability. And so if that's like more granular than that, then the model cannot like reliably follow that, then you're just wasting tokens. And so I think that also relates to the limitation that we did not investigate scaling, which I think will positively contribute to more controllable models. Oh yeah.
So one, maybe two questions. So like the most kind of like striking thing out of your results to me was that you have this like big improvement in the like positive helpful more than a like reduction in negative helpful. And so like just as somebody who's never worked on anything like this before, like intuitively, I think that like suppressing bad things seems much easier than like producing new good outcomes. So like I guess like Jason's comment about the like the qualitative results, I think kind of answers this a little bit. But like my first question is like what is your intuition for why you see the improvements on the like positive side of things? Like what is happening that's causing the model to like produce more positive, helpful outputs?
Yeah. So I think that's somewhat is stem from the like safety alignments of current models. Like you said, like it might be easier to like be very conservative and reject a lot of things. And I especially see this in llama models. So for example, I was trying to use llama 370 billion as a safety evaluator on like whether the prompt is like harmful in certain way or not. And the model just refused to respond to that query. So as long as you have certain kind of maybe harmful tokens in the context, the model just do refusal. So I think at least for llama model is trained to be like very conservative, and they're trying to like not let anyone like pick on their models saying that oh your model safety alignment has some problems, but at a big hidden cost of for like safe helpfulness in certain cases. And so I think like part of the takeaway from this work is we should also focus more on the balance between helpfulness and safety, which I think GPT models are much better at. So if you ask a GPT-4 models without filter for like harm classification, it would like not reject much. Yeah.
Yeah, so that does lead into my second question. Like, so a lot of my like experience with speaker verification is that like you have an operating point of your model, like maybe the task that we're working on, the situation where you're deploying a model, you don't care about all errors equally, and it gets like really hard to compare models because you can have these curves plotting the trade-offs and compute area under curve and all these things, but like when a model is actually being deployed, you don't care about the area under the curve. You care about a specific like operating point. And so like, again, like looking at your results table, when you see a 0 in one column, that tells me that that model has been like aggressively tuned to that case where you are suppressing particular outputs. And so I was just kind of curious, like if you've done any exploration, or I mean, maybe this is possible with the models you're working with, that like using that type of approach that just is simply more or like less. I'm not sure if I mean more or less conservative, but like if you had tuned it to not have that 0 there, would it not have maybe even more impressive results in the like again, like the positive helpful case, like have you done any sort of analysis on trying to like uncover like where those trade-offs are? Because I know that once you start like really pushing the bounds in one direction, it gets really hard to shave off those like last few percentage points. At least in the stuff that I've worked on.
Yeah,
So have you like looked into those sorts of questions at all?
I qualitatively look into those, like what are the prompts are easiest, like are the like easier for the model to improve. And I think the like a very interesting observation is that it really depends on the prompt's relationship to the safety conflict. And there are like prompts that are just there's no way to improve on that given safety conflict. So for example, if you just disallow building a bomb and if the prompt is asking about building a bomb, then it's essentially no, I don't see and there exists a response that can achieve both helpfulness and safety. And but you can do something like I cannot help you to build a bomb, but here's something like related to the knowledge of bombs that can help you navigate ethically. So that's actually what GPT does right now. But it really relates to the prompt distribution, and so that's why I think the corner cases are interesting. So because the model can have a lot of opportunity to gain on that edge, and similarly be like using Llama as a safety evaluator type of case.
Like the examples that the actual examples you showed, I thought were very interesting. Arguably the most informative slide.
Yeah, I really like looking at those examples, qualitative examples, and it's really fun to see.
There is a way to answer that safely. Say, here's the name of a person who can help you build a bomb, and give them the name of an undercover FBI agent.
Yeah. So related to that, I think so. We were thinking that whether this type of training can increase the creativity of models because you might have some creative answers that are both helpful and safe.